Math 7, Unit 4, Percent and Proportion, Lesson 7, Part 2, Percent Error, Notes. Measurement error, the amount of variation in a measurement from the actual amount. For example, Joe measured a box to be 13 inches. It was actually 12.75 inches. His measurement error was 0.25 inches. Estimation error, the amount of variation in an estimate from the actual or measured amount. Kylie estimates that it will take her sister 30 minutes to finish the dishes. It actually took her 35 minutes. Kylie's estimation error was 5 minutes. Percent error. The ratio of error, measurement or estimation error, doesn't matter, to the actual amount reported as a percentage. For example, Joe's percent error in his measurement was 0.025 out of 12.75 is 1.96%. Kylie's percent error in her estimation was 5 out of 35, 14.29% error. Percent error problems are done, well, if it's measurement, you've got an actual measurement and a measured. Well, the actual value and then what's measured. So maybe this is a car that has an odometer that's a little off. The actual distance was 506 miles and it was measured at 510.5. That's a difference of 4.5 miles. You divide by the actual amount, and this comes out to be 0.89% error. Actually pretty small. Estimation error. If I estimated something to be 39 centimeters and it ended up being 37.5, I'd be off by 1.5 centimeters. Compared to the actual length, which is, here's the measured length, it's 0.04, so that's 4% error. Determine the percent error in each situation. Julie was conducting a science experiment. She measured 13.5 milligrams of a product. The expected amount of product for the given reactants was 15 milligrams. So we're going to treat this as the actual, and this is the measured amount. The difference between the actual and the measured here is 1.5 milligrams. 1.5 milligrams compared to the expected 15 milligrams is going to be 0.1. Moving the decimal, this is 10% error. Next example, example 453. Ben estimates it will take him 30 minutes to finish the dishes after dinner. He worked from 6:15 to 6:48 p.m. Well, that is 33 minutes. So since he expected it to take 30 minutes and it took him 33, he took 3 minutes more than he expected to. We divide that by the actual amount. This comes out 0.0909, and it repeats that actually. Moving the decimal, this is 9.1% error. Seth estimates that the length of his afternoon walk was 2.5 miles. According to his GPS tracker, the walk was 2.65 miles. Okay, we start by finding out how far off Seth was. Seth was off by, well, less than a mile, 0.15 miles. We'll take that 0.15 and compare it to the actual 2.65. 0.15 divided by 2.65 is 0.0566, moving the decimal, 5.7% error. Dakota measures the weight of a large stone. She was supposed to measure the weight in kilograms, but instead measured in pounds. The 10.5 kilogram stone was measured to be 23.15. Well, first we subtract to figure out how far apart they are. 23.15 minus 10.5 is 12.65. We take the 12.65 and divide it by the actual amount, 10.5, divided by 10.5, and we get 1.204676. Moving the decimal, that's 120.5% error. Here we have an error that is greater than 100%. Now it is possible to have an error greater than 100%. On this, the Dakota's measurement was over twice what it should have been. Okay, on the assignment, number 1, you're going to find the percent error in historical scientific measurements compared to today's accepted values. Number 2, you're just finding some errors in some estimates. Someone estimated the weight of a pig. Someone estimated the number of people at a concert. Number 3 is a review on solving. Number 4 is a review of unit price, but there's also tax and discount involved, so that you can just calculate discounted prices. I'm trying to find the best deal on the candy bar, per candy bar. Number 5, you need to find the percent change between 2007 and 2013, well, the populations in those years. Once you find that percent change, you're going to apply that same percentage of change to find out what it would be in 2019. Number 6, a little bit of geometry, find the perimeters. Number 7, you're going to pick an object and measure, well, tell me what it is. Estimate its length, and then measure its length and find your percent error of your estimate. And then number 8, we use the number 3.14 as a stand-in for the number pi. Calculate what the percent error is if you use 3.14 instead of using pi.